Calculus kids, this is Dr. Callahan with week 8 Thursday. How are you guys doing? So today I am on campus, except I'm one of the committee members for the scholarship for Huck High School. And so we're meeting today to go ahead and look at some of your essays that students have submitted. And then we make a determination on who gets the scholarship. So I'm on campus, except I am in the film room, stuck in there with a bunch of other teachers looking at reading countless number of essays. So if you need any assistance, please keep in mind that I will be checking my emails regularly today. So if you have any questions, please feel free. Don't hesitate to email me to ask any questions that you may have. So go ahead and pause the video and answer the following 3 questions for your warm-up log. Keep in mind that today is week 8 Thursday, excuse me, and that this is due, your warm-up log for 300 points is due on week 9 Friday, so by next Friday. All right, let's go ahead and take a look at your updated grades for this class. So it is a 63.66% average, but this is your breakdown of your grades. And as you can see here that most of you guys are doing pretty well for the most part. There are a few of you guys who really need to bring your grade up a little bit higher. My suggestion is that you probably want to start off with your AP College Board because your Wednesday assessments are worth the most, followed by your Math Excel. And they are still open for you to access, so make sure you are doing that. For those of you guys that did complete the week 7 Math Excel, you guys did a good job for the ones that did do it. And then also for the AP College Board for week 7 Wednesday, the highest grade on that was 11 out of 12. So I curved it up to 11 out of 11. So if you have 11 out of 12, you now have 100%. And then if you have like an 8 out of 12, you can just take the 8 and divide it by 11. So that will curve it up a little bit. All right, I'm going to go ahead and add the assignment for today. Keep in mind, I will be taking attendance for you guys as well. So make sure you are checking in with me. And when you're done with today's lesson, upload it so that way you get the points for today because I'm not going to be there and this is all that you're doing. So week 8, Thursday, AP Calculus AB semester 2. And today we are going to be talking about some of the multiple choice questions that you have on your AP exams and the questions that actually involve trig inverse with integrals and derivatives. And we're going to talk about specifically with a culmination of different strategies that you use for integrals. Make sure you guys are checking in with me that you at least view the assignment by 9:41 a.m. That's the end of second period, so that way I don't mark you absent. And it is always due by 3 p.m. the date that it is assigned. All right, so with that said, let's go ahead and get started with today's stuff then. Here's a breakdown of what we're going to be discussing today in class. And let's take a look at your guided notes for today. It's going to be located on week 8, Thursday. And here is your first page. If you would like to go ahead and take a look at how this is done, it's a review, just go ahead and type in the link and watch the videos from here. This is the one that I'm specifically going to have you guys focus on today. It's just a summary of Chapter 5 integral review. There are 32 questions, and these questions were from previous year's multiple choice question on your AP College Board test. So I'm just going to go over this with you guys. If you do need more practice from class, again, it's talking about the strategies you'll be needing. And if you click on this link right here or type it in with a capital R, capital L, capital Q, it is going to take you over to the steps that you will need for this. So this is what you have. And then of course my work is shown below right here with the steps with all the 32 questions. So you're welcome to go ahead and view that. And if I go ahead and show it to you, that would be good too. So if you go ahead and do that, this is what you should have. All right, then let's take a look at the next page here. which is a summary of all of the formulas that you guys had in this class since the very beginning, starting with trigonometric formulas and then differentiation, integration, and then this unit, which we talked about with a lot of the derivatives and integrals of inverse trig functions. So this is the derivative. These are the three that you mainly use for integrals. And then, of course, we also talked about the derivatives of natural logs and integrals of natural logs here as well. And these are the different strategies to integrate. First one that we learned in the class is u substitution, integrals of 1 over u, inverse trig formulas. There are 3 of them. You could do this by synthetic division with long division, completing the square, integration by separation, and splitting the fraction into 2. So those are the different strategies that we've talked about in this class. All right, so with that said, let's go ahead and get started with the very first one. I would like you guys to take a moment to go ahead and highlight which formulas you still need to memorize. And then if you need to, you can go ahead and create little flashcards with them. So that way you guys can get that done. And they don't have to be anything fancy, you know, you just need to make sure you have that and in an envelope so that way you are able to access them and kind of memorize them. You don't want to do this like, you know, in April or May, you know, when you wait for the last moment, because I'm going to tell you right now, it's going to take you significantly more time to do this than to just do it the night before. It just does not work, you guys. All right, next what I'm gonna have you guys do is we're gonna take a look at this page right here. And we'll start with that. I'm gonna have you guys do number 1 and 2. They're fairly simple, pretty easy for the most part. So please go ahead and pause the video and give it a try. And if you're done with 1 and 2, feel free to move on from 3 to 32. You could just kind of skip around and see which one tickles your fancy and give it a try. All right, let's go ahead and take a look at the first one. With the first one, when you look at this is not really that difficult. It's just ln(u). So your answer here is just ln(u) plus c, and you want to integrate this between 5e to 1. And so if you plug this in, you're going to have your upper bound, which is to be ln 5e minus the lower bound ln1. Well, your ln5e is just going to end up giving you, because it's a multiplication, you could do a ln5 plus lne minus ln1 is just really ln1. You know that ln is going to give you a 1 right here, and so you have ln5 plus 1. ln1 gives you a 0, and this right here is your answer. So it is going to be D as in dog. Okay, let's go on to number 2. With number 2, the strategy is you want the denominator to be u. So then if your u is x plus 1, your du is just dx, and your dx is just du. So here's my integral, x plus 2 over u. Replace your dx with a du, and as you guys can see right here, it is not going to give you a perfect integration in this case because you have a x plus 2 right here. So your strategy is that, let's see if we can perhaps split the fraction. So another way of writing x plus 2 is just going to be x plus 1 plus 1. And if you look at this, what is x plus 1 again? Isn't that u? So then I have the integral of u plus 1 over x plus 1. Or actually, just I should say u plus 1 over u du. Now let's go ahead and split it. Integral of u over u du plus the integral of 1 over u du. So this gives you just a 1. And what is the integral of 1? Well, you guessed it, it's just x, okay? Plus the integral of 1 over u, that's just ln u plus c. And then what is your ln u again? U is x plus 1 plus c. And that is your answer, which is going to give you, again, D as in dog. Let's take a look at number 3. Okay, so for number 3, you got to ask yourself, what would you like your u substitution to be? My goal is to get everything in terms of u. And hopefully, if you look at your formula sheet, you can perhaps utilize one of the formulas to integrate this with everything that you have that's in terms of u. So if I were to do my u sub, I'm going to say let u probably be x squared. And let's see where this gets us. My du is 2x dx, and already I can see that there's an x there, so perhaps I can cancel it. Dx is du over 2x. So then I'm going to go ahead and integrate x times cotangent u, change the dx with a du over 2x. And looking over here, you can cancel the x, so you have the integral 1/2 in the front, cotangent u du. And what is the integral of cotangent? Yeah, it is going to be, if you look in your formula sheet, 1/2 ln sine u plus c. So your answer is ln sine u is going to be x squared plus c. And that is your answer. So this actually matches. Again, interesting enough, D as in dog. All right, let's go on to number 4. With number 4, it looks really, really kind of ugly. You can ask yourself, is there any way that I can rewrite some of the stuff on top? I see there's a sine squared, and you know that from trigonometry, sine squared x plus cosine squared x is equal to 1. And if I were to go ahead and solve for sine squared x, that's equal to 1 minus cosine squared x. So let's go ahead and rewrite that right here. So in equal cosine cube x minus 1 minus cosine squared x all the way over cosine squared x. Now let's go ahead and distribute the negative. So I have cosine cube x. That becomes a -1. That becomes a positive cosine plus cosine squared x plus 1. I'm sorry, minus 1 divided by cosine squared x. Okay, so then at this point here, it's in your best interest to just separate the fractions. Separate it, so you have 1, 2, 3 different fractions. So I'm going to have the integral of cosine cube x over cosine squared x plus the integral of cosine squared x over cosine squared x minus the integral of 1 over cosine squared x. Well, this is not easy enough. The cube and the square just gives you a cosine x. And you know that the integral of cosine is going to give you a positive sine x. So there's your first fraction. And then looking at this with the second part, that cancels and just gives you a 1. So what is the integral of 1? Well, that's just going to give you an x. And then what is the integral of 1 over cosine squared x? Well, that's just going to give you a minus tangent x plus c. If you hear music in the background, I'm so sorry. My daughter is messing around with my iPad at home. Okay, so your answer in this situation is going to be C as in cat. All right. Take a look at number 5. Give it a try on your own. So what do you want your u to be? Again, it's usually where the chain rule is. So your du is 2 du, or dx, I'm sorry. And then your dx is equal to du over 2. So rewriting this, I have the integral of secant u, change your dx to a du over 2. What is the integral of secant u? Well, if you look at your formula sheet that's given to you, integral of secant u is going to be a ln secant u plus tangent u plus c. So then that's going to be 1/2 ln secant u, and again, u is 2x, plus tangent u, so tangent 2x, plus c. And this right here is your answer. All right, let's take a look at example 6. Let's start off with a u substitution. So as I look at this here, if I let u be just the denominator x, I know my du is going to be dx. Well, that's not going to help me out at all to get rid of the ln x or square root of x. So that's a bad strategy. So then I have to go back to the drawing board and ask myself, well, what else can I have u be? Well, let's maybe give it a try to let u be ln x, because your du is 1 over x dx, and you can see there's a x on the bottom right there, so you can have dx is equal to x times du. That works perfectly. So then let's go ahead and rewrite this. Because you know that this is just ln x to the 1/2, I'm going to go ahead and rewrite this as ln u to the 1/2 over x times the dx, which is x du. So then looking at this part right here, my x's cancel, and I just have the integral of ln u to the 1/2 du. You can go ahead and bring your okay, so then remember, whoops, oh my goodness, excuse me, let's go back to this a second. Okay, so then as you look at this, you can tell that you have your 1/2, so you could bring it to the front. So you have 1/2 integral ln u du. Okay, and so when I went ahead and replaced it with a u, I realized that I put an ln right there, and I forgot that my u really is ln x. So if I replace this entire thing with u as ln x, really there's no ln, it's just u to the 1/2. So let me just go ahead and, sorry, get rid of that for now. So bring down the 1/2 down. You have a 1/2 u. And if you go ahead and integrate that, you have a 1/2 u. So then you will have to go ahead and integrate this, and you will have it 1/2 u du, sorry. And then looking at this right here, what's the integration of this? Well, 1 plus 1 is a 2. So divided by 2, you have 1/2 times 1 over 2, which is 1/4 u squared plus c. And then if you replace that u back, it's ln x squared plus c. And this is your answer. Okay, number 7 is something that's not super duper difficult. I'm gonna have you guys give this a try on your own. So pause the video and give it a try. All right, let's go on to example number 8. With example number 8, you have solved the differential equation. Your goal is to go ahead and figure out what is y equal to. So this one is dy over dx, so it is y prime. Now, if you do the integral of y prime, it just gives you y. So I would have to integrate this. If I integrate this piece right over here, you have a u substitution because your goal is to go ahead and get rid of all the things in terms of x. So it's in terms of u. And you, of course, you want to change your dx to du. So if you multiply dx on both sides, you have dy, which is y prime, is equal to the integral of 3x over 1 minus x squared dx. So I'm going to go ahead and say let u be 1 minus x squared. Your du is 2x dx, and your dx is going to be du over 2x, which is workable because I have an x right here, and the 3 will just be a constant. Let's go ahead and rewrite this. Integral of 3x over denominator is u times du over 2x. Your x on top and bottom cancels. You can bring that 3 over 2 to the left, 1 over u du, which is perfect because, ultimately my goal is to get, sorry, that has a negative 2x. Jeez, Callahan, that's a negative 2x, negative 2x, negative 3 over 2, sorry. So negative 3 over 2, ln u, your u is 1 minus x squared plus c. And that is your answer. I'm going to go ahead and skip 9, so please go ahead and work on it on your own. And that one involves an arc tangent, so I feel like we've gone over a lot of those questions, so I'm just going to jump ahead and go over to example 10. Okay, so as I look into example 10, I see the denominator has a square root, so I probably will have to use one of the 3 integrals of trig function inverse. But before I do that, I can't really match it up to one of the 3 equations because I would have to use completing the square. So looking at the denominator, here you have a negative, and I don't want to have a negative there. I want a positive x squared, so I'm just going to factor out negative. Minus 2x minus 8. Well, you want to go ahead and space that, so you have x squared minus 2x plus blank minus 8 minus blank. Your blank is just going to be a negative 2 divided by 2 squared, which is going to be a positive 1, so plus 1 and plus 1. And you know you created this piece right here, so it's going to be x minus 1 squared. Okay, and then here, -8 minus or minus 1 is going to be a -9, like that. But because you have this negative here, you need to go ahead and distribute it back. So really you have a positive 9 minus x minus 1 squared. And that is what you have in your denominator, and this is in square roots. So if you go ahead and compare this, this looks very similar to the equation that's going to be for arc sine. So here you have your a squared and minus your u squared. So matching that up, you can see your a is going to be a 3 and your u is going to be an x minus 1. So your du equals dx. Let's rewrite this. I have my dx, which I'm going to change the dx to du over square root of a squared minus u squared. So then you're just going to go ahead and put this into the formula of whatever it equals to. And you're going to get an arc sine u over a. So your u is x minus 1 over a, which is a 3, plus c. And this right here, whoops, is your answer. And if you look at that, that is going to give you B as in boy. All right, you guys, so we've gone over a few questions. I will recommend that you go ahead and keep working on this from 11 to 32. And once again, you do have the answers from the link. So I will see you guys next time. As always, stay safe and healthy and try to be kind to one another. Take care.